Hello, and welcome to another second grade episode of Math Matters. I'm Miss Beckett, and in today's lesson, we are going to practice estimating and finding the sum and difference of two-digit numbers and solve story problems. As you follow along today, think about how you are able to use an efficient strategy to help you solve problems. We will have an opportunity for you to reflect on your learning at the end of the lesson. In today's lesson, we invite you to continue working on your Portrait of a Graduate skills as you listen closely to the different strategies shared and see what connections you can make to your own ideas. As a creative and critical thinker, it will be helpful for you to see how you can think about problems in new and different ways. For today's lesson, you will need some paper and a pencil. Go grab those things and come right back. We will get started in 10 seconds. A few days ago, we used bundles and sticks to help us think about addition and subtraction. Do you remember how much a bundle like this is worth? It's worth 10. There are 10 sticks in each bundle. I will add some bundles and sticks each time, and you will tell me how many we have all together. Ready? How many now? 20. Now how many? 31. Now how many altogether? 44. How did you think about that? Maybe you counted on from 31. 10 more is 41. Then 3 more is 42, 43, 44. Or maybe you thought about there being 4 bundles of 10, which is 40, and 4 more ones, which makes 44. Awesome strategies. Let's keep going. How many did we just add? We were at 44 and we added 23 more. How many bundles and sticks is that all together? $67 altogether. How did you think about it? Great strategies. We will practice one more together. This time, we're starting with these. How many is on the screen? We're starting with 17. Now I'm going to add 2 bundles and 4 sticks. How many do we have now? We have 41. How did you know? Maybe you thought about it by starting at 17 and adding 2 bundles of 10, like 17, 27, 37. Then you added the ones, 38, 39, 40, 41. Or maybe you put the bundles of 10 together first. 3 bundles of 10 equals 30. Then you added the sticks and counted by ones. 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41. Maybe you realized you could group 10 sticks into another bundle of 10, giving you 40, and then 1 more stick was left, which makes 41. What you did was just solve the equation 17 plus 24. You can think about these strategies as we continue our learning today. This year, you might remember talking about estimation in math class. An estimate is a reasonable guess or approximate calculation. It is not meant to be an exact answer, but will come close to the real answer. Sometimes we estimate things like how many Skittles are in a jar. But we also use estimation in math to help us see if our answers are reasonable. For example, I wanted to play baseball, and I know to play baseball, I need a ball and a glove. The ball cost $16 and the glove cost $28. I had $40 to spend. Do you think that the total cost of these 2 items is more or less than $40? We could use estimation to see how much they cost and see if we'd have enough money to buy them. What do you think? Will we have enough money? How do you know? Estimate first. then solve. I was thinking about estimating, and I know 28 is close to 30. 30 and 16 make 46, which is greater than 40. If I were to really solve for the cost of the ball and glove, my answer should be close to my estimate of 46. My estimate helped me to see if the real answer I get is reasonable and makes sense. After I made my estimate, I used a strategy to solve just like you did. I used similar thinking when I made my estimate to help me solve. Maybe you thought about 28 being close to 30, and I know 30 and 16 makes 46. Since I added 2 extra from the 28, I need to take that away at the end, so that means I'd have $44. $44 is greater than $40, so I wouldn't have enough money. That was a strategy I thought about in my head. Maybe you showed your thinking on paper using a tool like a number line. Here's the number line Amber used to figure out the total cost. What do you notice? Maybe you notice she started at 28, the price of the glove. Then she added a jump of 10 and a jump of 6. Where did her jump of 10 and 6 come from? Why did she choose those numbers? That's right, 10 and 6 is 16, the price of the baseball. Jerome also used a number line. Let's look at what he did. What do you notice? I noticed Jerome made a jump of 2 first. Why do you think he did that? He wanted to get to the friendly number, or next 10. So the numbers would be easier for him to work with. Where do you see the price of the baseball in Jerome's strategy? It's the jumps on the number line. He added 2 to get to the friendly number 30, then 10 more to bring him to 40. Then 4 more brought him to 44. 2 plus 10 plus 4 is 16, the price of the baseball. Look at Amber and Jerome's number lines. What is the same about them? Maybe you notice they both start with the price of the glove, $28. Maybe you notice they both ended at the total cost, $44. Maybe you noticed all of their jumps add up to 16. What are some things you notice are different about Jerome and Amber's number lines? Maybe you notice that Amber made a jump of 10 first, while Jerome made a jump of 2 to get him to the next friendly number. Nice job noticing things that are the same and different between Amber and Jerome's strategies. Now that we know estimating can help us determine if our answer is reasonable, let's see how we can use that for this next task. A wallet has $61 in it. Which item can we buy with the amount of money in the wallet? The soccer ball, because $27 is less than the $61 in the wallet. We cannot afford the tennis racket, because $95 is more than $61. What equation can we write to represent the money that would be left if you bought the soccer ball? That's it, 61 minus 27. What strategy could you use to estimate and then find out the amount of money left in the wallet after buying the soccer ball? Use your paper and pencil to solve this problem now. Estimate first, then solve. We will share our strategies in a minute. Let's come back together. First, I estimated to see what a reasonable answer would be. I know 61 is close to 60, and 27 is close to 30. 60 minus 30 equals 30, so I know my answer is going to be close to 30. I will come back to my estimate at the end after I solve to make sure the answer I got makes sense and is close to my estimate. What strategy did you use to solve 61 minus 27? Maybe you used a number line to represent your strategy. We can show many strategies on a number line. Here is one strategy I saw a second grader use on a number line to solve this problem. They started at 61 and jumped backwards 1 to get to a friendly number 60. Then 10 more, 10 more, and 6 more. Where do you see the 27 they took away on their number line? The jumps they took away. Minus 1, minus 10, minus 10, and minus 6 is the 27 that's being subtracted. Where do you see the answer on their number line? That's it, the number that you land on, 34. Maybe you thought about this problem a little bit differently. Maybe you thought about splitting 27 into 20 and 7. Then we could start at 61 and take away the 20, and that brings us to 41. We took away the 20 from the 27, and we still have to take away the 7. So 41 minus 7 equals 34. Maybe you thought about a different strategy than the two that I shared with you today. But let's come back to our estimate. When we solved the number sentence, we got a difference of 34. That is pretty close to our estimate, just 4 away, so our answer is reasonable. If we solved this and got an answer of 46, would our answer be close to our estimate? No, 46 is not that close to 30. So that's a great clue as a mathematician that something might be off, and we should go back and check our thinking or try a different strategy. Estimates really help us to see if our answers are reasonable and make sense. You all worked so hard solving some math tasks. A tool you may have used in your classroom that we haven't talked about yet is the hundreds chart. We're going to play a game on the hundreds board now. I like to call this game 100 board magic. I will tell you what number to start on and then show you some arrows like these. The arrow pointing towards the right means you go over one space to the right like this. The arrow pointing towards the left means you go over one space left like this. The arrow pointing up means you go up on the hundreds chart one space like this. What's happening when we go up on the hundreds chart? We're subtracting 10. The arrow pointing down means you go down one space like this. What's happening when we go down one space on the hundreds chart? You got it, we're adding 10. Okay, here's our first round of hundreds board magic. I started at the number 23. I went down, then right, then down, then right. What number did I land on? Going down adds 10 and brings me to 33. Right adds 1, and that's 34. Down adds 10 more, so that's 44. And going right again adds 1 more, so that's 45. I ended at 45. What number equation would match what I did? Maybe you thought about it as starting with 23 plus 10 plus 1 plus 10 plus 1. Or maybe you thought about adding the value of all the jumps we made on the hundreds chart, which was 22, and added it to our starting number. So 23 plus 22 equals 45. Let's play one more round. I started at the number 77. I went left, left, up, left, then up. What number did I land on? Going left subtracts 1, so that's 76. Left again subtracts 1 more, so then I'm at 75. Going up subtracts 10, so now I'm at 65. Going left subtracts 1, so I'm at 64. Then going up subtracts 10, 54. We landed on 54. What equation would match what we just did? Maybe you thought about subtracting each arrow. 77 minus 1, minus 1, minus 10, minus 1, minus 10. Or maybe you thought about subtracting the value of all the jumps we made on the hundredths chart at once. 77 minus 23. The hundredths chart is a great tool to help us with adding and subtracting. If you have a hundredths chart at home, you could play this game after our lesson today. Even if you don't have a hundredths chart, you could look one up on Google or even practice counting by tens and ones out loud with someone at home. Today's lesson was a review of how we can use a strategy to find the sum and difference of two-digit numbers and solve story problems. Reflect on your progress towards our learning goals by selecting which emoji best matches how you're feeling about today's lesson. A smiley emoji if you got it and are feeling good, a thinking emoji if you think you understand but need more practice, and the confused emoji if you feel like you have more questions or could use some help with today's lesson. As you think about the learning goals for today, maybe there's something new you learned, like a new strategy that you don't want to forget and try next time. Or maybe there is something we talked about today that you still have questions about. Take a minute to record your reflections on today's lesson and save them for the next time you're able to check in with your teacher. Mathematicians are creative and critical thinkers, always looking for connections and new ways to solve problems. What new connections did you make today? Did you challenge yourself to try a new strategy? Thank you for joining me for today's second grade episode of Math Matters. I'm Miss Beckett. Have a great day and keep on counting.